Let's find the gradient of f at the point x equals 1, y equals 0, and z equals pi over 2. Our function f is given to be a function of x, y, and z equal to x e to the 5y times the cosine of 3z. So since f is a function of these three independent variables, to evaluate the gradient of f, we're going to have a vector, a three-dimensional vector operation, where the gradient of f is equal to the partial derivative of our function with respect to x for the x component, plus the partial derivative of our function with respect to y for the y component, plus the partial derivative of our function with respect to z for the z component. Well, let's evaluate each of these partials in turn. Let's start with the partial derivative of f with respect to x. Now remember, a partial derivative with respect to a variable is taken by differentiating the function with respect to that variable while treating every other function as if it were a constant. So in this situation, our function is x e to the 5y cosine of 3z. Well, we will treat y and z as constants. So I'll pull them outside of the differential operator. So we have e to the 5y cosine of 3z, and then this is times the derivative of x with respect to itself. Because now that I pulled those functions outside, or those variables outside of the derivative in essence becomes an ordinary derivative that we know how to calculate. So this means that the partial of f with respect to x is just e to the 5y cosine of 3z, where we recognize that the derivative of x with respect to itself is just 1. So here is the x component of our differential, or of our gradient of our function. Let's now find the y component of the gradient of f. In order to find the y component, we're going to need to evaluate the partial derivative of our function with respect to y. Since it's a partial derivative with respect to y, we're going to treat all other variables except for y as constants. This means that we can write x in front of the partial derivative operator. We can also write cosine of 3z outside the partial derivative operator, leaving us with the derivative with respect to y of e to the 5y. This means that the partial derivative with respect to y of our function is equal to x cosine of 3z 5 e to the 5y, which is the derivative of e to the 5y with respect to y. And this ends up being the partial derivative with respect to y is just 5x e to the 5y cosine of 3z. Now that we have the x and the y components of our function, let's find the z component. So the z component is found by taking the partial derivative of our function with respect to z. So the partial derivative of our function with respect to z is evaluated by treating every variable except for z as constants. This means that we can pull out the x from our partial derivative operator. We can also pull out e to the 5y out of the partial derivative operator, and that leaves us with the derivative with respect to z of cosine of 3z. When we evaluate this, we get the partial derivative of f with respect to z is equal to minus 3x e to the 5y sine of 3z. We have now found the three components of the gradient of this function f. So let's write it out. The gradient of f of the function of three independent variables x, y, and z is equal to e to the 5y cosine of 3z for the x component plus 5x e to the 5y cosine of 3z for the y component, and minus 3x e to the 5y sine of 3z for the z component.